Hi everyone, welcome back to the channel. Today we are going to discuss about another common electronic problem, finding the collector voltage across the transistor in a multi-transistor circuit. Specifically, we'll focusing on finding VC2 in this circuit right here. And we know that the base voltage of first transistor Q1, that is equal to VB1, which is equal to 0.7 volt, and emitter to base voltage of the second transistor Q2, that is VEB2, is also equal to 0.7 volt. Our ultimate goal is to find out the value of VC2, the collector voltage across transistor Q2. To figure out this, we need to think about what determines the voltage at collector. That's right, it's the collector current IC2, and which is flowing through the resistor 1.2 kilo ohm. If we can find IC2, we need to simply apply the Ohm's law to find the voltage drop across the resistor 1.2 kilo ohm and then determine the voltage VC2. But how do we find IC2? Well, for a transistor, the collector current is related to the base current IB2 by the transistor current gain beta. In this case, we were given the beta is equal to 50, then the IC2 is equal to beta times IB2. Then IC2 is equal to beta times IB2. Okay, so now our focus shift to find the current IB2. This is the base current of secondary transistor Q2. To find the base current, we need to know the voltage at the base of the secondary transistor, that is VB2. Let's look at the first part of the circuit. Here VCC and VB1 is directly shorted, so that the voltage VB1 is equal to 3 volt, and the base to emitter voltage of first transistor, that is VBE1, is equal to 0.7 volt. Since VB1 is given as 0.7 volt, this likely refers to the voltage difference between base terminal and the ground reference. And VBE1 is voltage drop across the base to emitter junction. Therefore, the voltage at the emitter of first transistor, which we call as VE1, is equal to VB1 minus VBE1, which is equal to 3.3 volt minus 0.7 volt, which is equal to 2.6 volt. Now here is the crucial point. Notice that the emitter of the both transistor is connected together. This means that the voltage at the emitter terminal of the secondary transistor VE2 is equal to VE1, and we can call it as 2.6 volt. We already know that emitter to base of the secondary transistor VEB2 is equal to 0.7 volt. Since VEB2 is defined as VE2 minus VB, and once we rearrange the term to find the VB2, then VB2 is equal to VE2 minus VEB2, which is equal to 2.6 volt minus 0.7 volt, and then we will get 1.9 volt. Great, now we have VB2. Now we can find the base current IB2. Looking at the circuit, we see that the base voltage of secondary transistor is connected with 10 kilo ohm, and which is then connected to the 1.5 source volt. We can use the Kirchhoff voltage law here. According to the Kirchhoff voltage law, KVL, voltage across the resistor R1 will be, that is VR1 is equal to 1.9 volt minus 1.5 volt, which is equal to 0.4 volt. Now by using the Ohm's law, I is equal to V by R. The base current IB2 is equal to 4 volt divided by 10 kilo, which is equal to 40 microamps. We are almost there. Now that we have IB2, we can find the collector current IC2. Remember, the IC2 is equal to beta times of IB. That is equal to 50 times of 40 microamps, which is equal to 2 milliamps. Finally, we can find the collector voltage VC2. The VC2 is the collector voltage across the collector terminal of the transistor Q2. Since the collector is connected to the 1 kilo ohm resistor and then the voltage source, the voltage drop across the resistor is given by the Ohm's law. V is equal to IR. So that voltage drop across the resistor R2, VR2 is equal to IC2 1.2 kilo ohm, which is equal to 2 milliamps into 1.2 kilo ohm. If we simplify, we will get 2.4 volt. Therefore, the collector voltage VC2 is equal to 2.4 volt, and that's how we find the collector voltage VC2 in this circuit. We broke it down step by step, starting with given information and using the fundamental transistor relationship and the circuit law. I hope you found this explanation helpful. If you have any question, feel free to leave them in the comments below. Don't forget to like this video and subscribe for more electronics tutorial. Thank you for the watching. I will see you in the next one. Thank you. Thank you very much.